I'm Nate, and today I'm talking a bit about Tamagui. So what is that? It's sort of three things in one. The core of it is this style library that also lets you bring along a bit of a design system, a universal style library, I guess is we're calling it these days. So it just works on native and web with the same APIs. On top of that, what I think is probably the more interesting part is this package called Static, which is an optimizing compiler that it works alongside core. And then on top of that, there is a kind of like a complete component kit and UI system that works on native and web. And I'm actually not going to really talk much about that today, just because there was too much stuff to talk about with the first two, and I think they're probably a little bit more interesting. So I thought it was kind of interesting and relevant to start out by talking about why I built it, because I got this question from a lot of people early on, and it was sort of like in the form of like concern, like, are you sure you want to build a UI kit? Because it's a lot, and I think one of the answers to that is just that I don't really think ahead very well. And I wasn't really 100% aware of what I was signing up for, because I think when you're building a UI kit, especially one that works across a lot of different platforms, you actually end up with this like multiplicative problem where you're supporting multiple operating systems, 4 different JavaScript runtimes, server and client. With an optimizing compiler, you're also having to test everything when it's optimized versus not. 2 different input modalities, headless versions, styled versions, and also when it adapts to native versions of everything. Tamagui works with different animation drivers, which I'll talk about in a bit. So there's also testing across 3 different types of animations, and you end up with kind of an insane amount of combinations. So. But the real answer was kind of ironically that I was trying to save time building an app, and and then I ended up not ever really building that app and building Tamagui instead. And I guess the reason behind that was that I was using React Native Web at the time, and my app was feeling kind of bad, and basically it was feeling slower the more I added features, and why was it kind of feeling slow? It was actually 2 reasons, I think. Not just the fact that it was loading a lot of JavaScript, especially on the web, where it's a lot more sensitive to that sort of stuff, but also because implementing a lot of features that in CSS are very natural actually were quite cumbersome on native. So media queries, I was having to write a hook and a set state and kind of thread a lot of state around. Same thing with pseudo styles or like interactive styles, so like hover and focus and press events. You have to kind of do quite a bit of code. For themes, like changing from dark to light mode, I was threading values down context and having to re-render every view every time I wanted to change a theme. And also just generally, if you have all of your styling in JavaScript, you're paying quite a cost in terms of your bundle size and the parsing time up front. And then I think there's this kind of like one underappreciated aspect of when you write a universal app today, which is that I was trying to abstract all of these different features that were cumbersome to write, like media queries and pseudo styles, into like a stack view that I had designed to make it much easier to write. But then the problem is that all the leaf nodes, and basically the majority of the nodes in your application, are now paying the extra cost in tree depth because you have this stack view that makes it easier to, say, write a media query, but now instead of rendering to a view or a div on the web, you're rendering to a stack view, which has to run a bunch of hooks, and React has to deal with one extra layer. So I think that verbosity, both in terms of like how much you have to write and how much code you have to thread in order to try something out, is kind of the death of creativity, which is very important when you're trying to design and come up with like a new product that you're not exactly sure how it's going to work. And so I like this little example that I put together, which is that, say you're a painter that likes to paint landscapes, and and you went to go make like a brush stroke, and it took like, say, a few seconds until you actually saw the brushstroke. And I just don't think you'd be a very good painter if that was the case. And that's kind of what it felt like coming from like a web world where CSS was just so simple to write and so quick that I could try out different styles and different ideas. But the idea of having to add an event and add a set state and then update that in the render function made me feel like I was painting in slow motion. And so the question is, can we solve that? And I've come up with this like sort of diagram where it's like a choose two, or a trilemma, I guess is what some people call that, like the Cap Theorem, so to speak, which is that you can sort of choose two of these options. You can have one code base and have it feel native, or you can have it be multi-platform and feel native, or you can have one code base and be multi-platform, which I'll break down in a second. This is what I was choosing at the time, which is that I had abstracted things to make it very easy to write. So I had this very nice stack view that let me write very simple media queries and hover styles and all of that, and it worked across platforms with one code base, but my app was feeling quite slow due to all that extra JavaScript. A different option is just to not ship it on both native and web, obviously. Pretty straightforward. It's going to feel native, and you'll have one code base. And then, I think a common option with like bigger companies is that they will write everything twice, and obviously that gives them quite a bit of performance. But I do think it's kind of underappreciated that this has a huge cost. Like even at the biggest companies, having multiple teams have to deal with each other and plan and coordinate features. The ideal team is a small group that just like is able to kind of control everything. And so I think while Tamagui definitely helped me as like an individual developer, I think it still has a lot of value for bigger teams that want to move quite fast. And so this is where I ended up in the middle, which is that I just never actually shipped that app because I was trying to solve this trilemma. But I do think that I found somewhat of an answer, and it's, I think, an answer that's just always been true in kind of the history of computing, which is that we make higher level abstractions, and then we make those actually perform somewhat better through optimizing compilers. And so that was what I worked on with Tamagui. How does it do that? Well, most of the optimizations are actually on the web because the web has a lot of features that do run a lot faster than JavaScript, and namely that's CSS. So media queries are media queries. Interactive styles can be generated in CSS. Themes can be generated as CSS variables. And then also just in general, the more JavaScript that you can remove and replace with CSS, the faster it's going to feel. And then I think this is kind of like the underappreciated one, of course, which is flattening. You want to be able to have these styled views that you can define that are much easier to work with, but in the end, you would like to be able to render them out to something like a div on the web or a view on native and not pay that extra cost of rendering another component. So this is Tamagui core, which is the style library. I think I put the Stitches logo over there because, to be honest, it's just about the exact same API. You have typed themes and typed tokens. You have media queries and pseudo styles, and you also have this concept of variants, which is just a kind of a simple way to add typed properties, custom type properties that expand into styles. And I think one thing that actually was kind of cool about variants is that you can wrap these styled views as many times as you want. You can just keep kind of taking like this heading, for example, and make like an H1 on top of it or an H2 on top of it and change a few values, and you build up this sort of like vocabulary in your design system. But you don't actually, it's not actually adding an extra layer of components in between. It is just merging the various variants and still giving you nice types and TypeScript and all that, which is great because the compiler, a compiler can only understand so much dynamic behavior. And variants are like a nice limited amount of functionality that still gives you a decent amount of power without de-optimizing a compiler. OK, so I'm not going to really go over all of these, but these are some of the features that Tamagui Core brings on top of something like React Native Web. It is fully compatible with all of the React Native APIs, and everything that it does works 100% the same on native and web. And I threw this slide in. I like Tailwind, by the way. I think it's a great library, but I do think that it's relevant to compare it with Tailwind. It takes a lot of similar sort of the upsides, and I think the nice idea is that Tailwind has, like, being able to write inline styles with shorthands, generate minimal CSS from what you use, and also that works on native and web. It has a definite downside compared to Tailwind on the web, which is that you do bring along some JavaScript. One of the decisions that I made with Tamagui was to make everything work at runtime, so you don't actually have to use the compiler. It's not Zero.js, which I think is kind of popular these days. But I do think that brings you some upsides, which I'll talk about in a second. But and I think one counterbalance to that extra bundle size is that the compiler tends to do a pretty good job of actually neutralizing that, and even in some cases making your app, I think, feel faster than, say, like a typical zero runtime JavaScript library. Some upsides, though, is that everything is typed with TypeScript, and you don't need any editor plugin. You can do really dynamic styles, so you can sort of throw anything you want at it, and it will work without having to worry about whether or not, like, the plugin will pick it up. And one really nice thing is you can merge your properties down. So I think Tailwind has something like Tailwind merge, but just by default, since Tamagui is using flat style props, you are able to just kind of like really granularly control whether or not your component lets an external user override some style properties or not. And again, you can use dynamic styles, and well, I think I covered the properly merged props, but also it's kind of nice that you can destructure style properties and also then go back and restructure and add them on. So I think you're basically using JavaScript, which is really nice, and so you have a lot of control over how you manage your styles and manage your components. And then a powerful theme system, which I will talk about next. So one of the main principles of Tamagui is that it tries to avoid re-rendering as much as possible, which is very important, especially for performance on both native and web. And I'm going to kind of show how that happens through two of the more interesting features, which are animations and themes. So there's 3 animation drivers, like I mentioned. And the cool thing is you can swap them out depending on the platform. So if you want to have nice spring animations on native, you plug in the reanimated driver like so, and you get this kind of typed animations that you can access on any view. And then on the web, if you wanted to save some bundle size, you can plug in a CSS driver, and as long as you match up all of those properties, they'll all be typed, and you can just swap it out at any time, and so your web app can have a lot less bundle size. This is a quick example just showing kind of how animations work. You have a stack view, you give it the animation property, and then all of these properties will animate, and I can hover on this, and it does a little spring effect, and that's that. And so here's how you define, and then the themes are the other thing, and I'm going to show how they kind of work together to avoid re-rendering in a way that I think is pretty cool. When you define themes, again, it's just JavaScript objects. They're meant to have the same structure. So basically, background and color here should be across all your themes so that when you change out a theme, it's kind of always there for all your different components. They generate CSS variables on the web. And here's an example, just kind of very arbitrary example showing using a theme, you can set the theme. These are all imported from Tamagui Core, by the way. I just wasn't sure if I had enough space on the slides to show the imports. But theme, stack, and text all are just built into Tamagui Core, and then you can extend them from there. But you can basically set a theme and then look for the background color, and it will pick up the background color and color from that theme. And then likewise, you can abstract your widget out now, and of course set the theme for that entire subtree. set it to dark, and of course it will change to dark. And also you can nest themes and change them as many times as you want down the tree, so you kind of have quite a bit of power in terms of changing the look and feel of different sub parts of your tree. And themes also have this little nice feature called inverse, which just automatically works with dark and light mode, because a lot of people like to have, say, like an inverse button that looks like the opposite color. And this is really nice because, you know, if your top level thing is like a prefers color scheme, then you don't have to worry too much, like, is it dark, and then change it to light and do a bunch of logic. You just kind of inverse it, and it works. And then I think this is the cool part about Tamagui themes, which is that you can have sub-themes, and they're defined with an underscore, like this. So here we can add on 2 more themes, which is a light red theme and a dark red theme. And again, it's, oh, you know what? The white and, oh no, that's right, white and red. Okay, I thought maybe I didn't put the right values there, but I did. So yeah, we're just adding like a light red theme and a dark red theme. And then again, you can now nest your themes. And so you can set theme equals light, and then down somewhere further below, you can set it to be red. And now you have your light red theme applied to that widget. Again, we can just use that little inverse thing, and it's actually smart enough to change from light red to dark red in that sub area, which is, I think, pretty cool. And one last thing to note about sub-themes is they actually go all the way down to the component level. So with your style view, you can give it a name. So this one's named square. And then if you define a theme with a capital, so light square and dark square, you can actually apply a theme directly to any component. And I think this is actually pretty interesting in terms of being able to share code and publish widgets that other people can use, because they can go ahead and just rechange the look of anything that you've published while not having to dig deep down into the internals or like thread props down in a very weird way. So I just wanted to show a few examples. This is kind of just like an overview of a variety of the components that come with the Tamagui theme. I think the contrast on this monitor is not quite as good as the contrast on my screen, but this is a dark theme, for example, and then a light theme. And that's just obviously changed out at the root. And then here we're showing dark plus inverse by inversing the card, which is, again, pretty nice. You can sort of just change it at any level of the tree. I made a little outline theme, which, again, I'm not sure the contrast is super high here, but it just basically made all the borders much stronger. And then a light theme, which, once again, kind of gives you that like sketch outline type look for more of like a prototyping type design. This is a dark purple theme. Again, it's just tweaking a bunch of things. And then a dark purple alt theme, which is a further level down, which kind of just increases the brightness and lowers the contrast. Useful for things like having like a subtitle that's less emphasized, for example. And I think the idea here is that with Tamagui, you kind of get close to this like dream of Winamp, where you could have people publish themes and actually change every single part of an interface without actually having to go in and change any of the code. It's not quite there yet because the style system in React Native doesn't support things like, you know, background image or linear gradients and stuff like that. So you're a little bit more limited in what you can change. But I do think as we keep adding on these nice style properties to React Native, we'll get pretty close to being able to have apps that you can basically fully control the look and feel without having to dig in and hard code a bunch of different values and change them. And then again, I kind of talked a little bit about re-rendering and avoiding re-rendering, and so I think it's cool to show how it all comes together with themes and animations. So here's a stack view again, where we have an animation, we have a background color that's using one of your theme values that you've set, and then we change it when you hover over the stack view. And the cool thing is, if you're using the CSS driver on the web, it's going to actually read the theme value into a CSS variable. And that means that it knows internally that you're not actually dependent to, that's not a value that needs to be changed when I change a theme somewhere up above. So it won't re-render as you switch from dark mode to light mode. And that was one of the things that was making my app feel very slow, was when I was just using a bunch of hooks and threading a bunch of context values down. When I would change from a dark to a light theme on my app, it was like a 400 or 500 millisecond main thread pause, whereas now the Tamagui homepage has hundreds of elements on it, but you can switch between dark and light mode instantly because it's only re-rendering a very small amount of components. For example, if you did have a Spring driver, like the reanimated or React Native animated driver, then when you do an animation, it needs to actually grab the real value of the color and not the CSS variable, because those drivers don't work through CSS variables. They work through the actual raw color value. And so this stack view would actually re-render as you change the theme, but none of the other views that don't use the theme or that don't use the reanimated driver would actually re-render. So you get this kind of really nice vertical integration, I think, between all the different features in Tamagui core. OK, and so then on to the cool part, the optimizing compiler. Tamagui static does 4 different things to optimize your apps. The basic thing is to extract CSS at build time. And then tree flattening, which I will explain in a second, which actually works alongside partial evaluation. And then hook removal, which I don't really have a slide for, but basically Tamagui has hooks for use theme and use media. And if you use those as as values for your styles, it actually does a bunch of analysis to figure out, OK, well, these are just used for plain styles that we're going to generate CSS for. So we can actually just turn that into CSS and remove those hooks from your code to save you a bit of rendering time. Here's an example of how it works. So on the left is what you would write, and on the right is what the compiler would output. It does evaluation of a variety of different things. You can use logic, including nested ternary logic or spread values. It handles quite a few different things that it can analyze. And the my custom color there would be like an imported value. It actually will do evaluation of cross-module boundaries. So you can have like your constants in a different file and import them and use them as color values. And it will try and analyze that at build time and see if it can just fully optimize it away. And it's very nice. I mean, the difference in performance when you have a large page is quite significant, not just because it's using class names, but also because it's rendering out to an actual div and H1 rather than rendering to an extra level of depth. Especially at these leaf nodes, because style views are everywhere. You can have hundreds of them on a single page, and so you're actually basically flattening your tree by almost half in many cases, and just getting this very, very efficient output. There's obviously some CSS that's output too on the right. I'm just not showing it, but it emits CSS in a plugin that works alongside Vite or Webpack, or it works with Metro through Babel. So just a brief explanation of how that sort of works with partial evaluation. Basically, it's a Babel plugin. It checks for JSX expressions. It will go through and normalize all the different ternaries and spreads and nested logic that it finds. Babel has this really nice helper called get all bindings, where it traverses upwards within the current scope and tries to grab all of the static bindings that it can find and give them back to you. It will then analyze imports that you whitelist. We actually don't analyze every import because that could get kind of insanely expensive, but you can give it some whitelists like your constants file, your colors file, for example, and it will go and try and analyze those and require them in. And then it takes all of those bindings and it uses this very cool node module that I never heard about. I actually haven't seen it in use much at all, but the node has this thing called VM, which lets you run node code from node. So it'll pass in the source, all of these static bindings that it's found, and then try and basically analyze that code. So you can even do stuff like, in the higher scope, you can have like some addition or like multiplication of different values, and as long as it can figure that all out, it will still go ahead and flatten your views. Just a little example of how that looks. On the homepage of the Tamagui website, we have this little demo of like a Safari browser that's got a bunch of different divs and stuff, obviously, to make those tabs and the different sections there. It's about, it's a small little area of the homepage, but actually within that just one area, it is flattening about 50 different components from being stacks or views or whatever into divs. And this is what it looks like. On the left, you can see, I don't know if it's big enough. Yeah, I guess it's not too bad. you can see a bunch of different views. Like we have the H1 view. Oh, I've got my cursor here too. So this H3, for example, is like my own custom H3. It uses my design system. It uses my tokens, my size tokens, and everything. And then the output is just a very nice, clean, flat div, or H3 in this case. I did a little bit of profiling for this and kind of tried to keep it consistent. And I did a bunch of runs, and what I found was that the home page on average would take about 660 milliseconds until it fully finished rendering. Now, granted, the Tamagui homepage is trying to show off like every feature in Tamagui, so it's quite heavy. It's showing like a bunch of themes that you normally wouldn't have, and all the different animations and features. But nonetheless, without the compiler, it's about 660 milliseconds until it finishes doing all the animations and rendering. And when I turn on the compiler, it takes about 600 milliseconds, so you're getting about a 10% increase in startup time. Likewise, the Lighthouse scores seem to be about a similar amount better. It goes from about an 80 to a 91. That was an average of 4 different runs that I did, which I think anyone that's struggled with Lighthouse knows that the last 20% is kind of the hardest 20%. And so it's pretty nice to be able to just give yourself 10 or more points without having to do anything. And I think kind of like a final takeaway from this that I think is very important is that when you do get speed along with simplicity, it really helps with creative expression, because now you can do these inline styles. You don't have to worry too much about if you're costing your app a bunch of performance. You can just kind of throw things in there, iterate a lot, and then turn on the compiler before you go to production mode and get back most of that performance that would normally be costing you quite a bit. And so that's kind of a brief overview of Tamagui. I wanted to do quite a bit more, but it was taking like 40 minutes for my talk a couple days ago, so I pulled out a few slides. So I just wanted to say that I think CSS and JS is back, and that is my talk. Thank you.